What is bistatic radar and how does it affect stealth? Imagine a system that can detect objects without relying on a single source of signal transmission and reception. This concept is at the core of bistatic radar technology, which has significant implications for stealth capabilities. Bistatic radar involves two separate locations. One station transmits the radio waves, and a different station receives the signals reflected from targets. This setup contrasts with monostatic radar, where the same antenna transmits and receives signals. In a bistatic configuration, the transmitter and receiver are positioned at different points, often separated by considerable distances. When the transmitted radio waves encounter an object, such as an aircraft, some of the energy bounces back toward the receiver. The receiver then analyzes the reflected signals to determine the presence, location, and sometimes the characteristics of the target. The separation between the transmitting and receiving stations allows for unique detection angles and can help in identifying objects that might evade traditional radar systems. One of the key factors influencing stealth technology is the way radar signals interact with aircraft surfaces. Stealth designs aim to minimize the reflection of radar waves by shaping surfaces to deflect signals away from the source and by using radar-absorbing materials. These techniques are highly effective against monostatic radar because the same system both transmits and receives signals from a single point, making it easier to detect the characteristic reflections of stealthy objects. However, bistatic radar complicates this picture. Since the receiver is located elsewhere, the angles at which signals are reflected and received differ from those in monostatic systems. This means that stealthy aircraft, optimized to evade signals returning directly to the transmitter, may still produce detectable reflections at the receiver's location. The different geometries can reveal the presence of an aircraft, even if it is designed to minimize direct radar cross-section in monostatic systems. Furthermore, bistatic radar can utilize multiple receiver stations to create a network of detection points. This network enhances the ability to locate objects that might be invisible to traditional systems. It also complicates stealth tactics because aircraft must now contend with multiple detection angles and signal pathways. The overall effect is that stealth technology must be more sophisticated to counter the diverse detection methods enabled by bistatic radar systems. In summary, bistatic radar involves separate transmitting and receiving stations working together to detect objects. Its unique geometry and detection capabilities make it a powerful tool against stealthy targets, requiring ongoing advancements in stealth design to stay ahead of evolving radar detection techniques.